Horned dinosaurs are super cool. As you get to understand them more and more, you might find that there is too much going on. The mascots of the horned dinosaurs are Centrosaurus, the major face of the Centrosaurs, Chasmosaurus, the major face of the Chasmosaurs, and Triceratops, the last and biggest of the horned dinosaurs. These dinosaurs have become wastebaskets for paleontologists to throw new species into, and one that has been sitting around in the Chasmosaurus bin for almost 100 years has finally got the boot. Let's look at the fossil proof and see what it says. Special thanks goes to paleontologist Danny Barrera Guevara for helping me out with this video. Hello! I've turned myself into primordial ooze! I thought it would be a fun way to transition between my voice, live action footage of myself, and cute little characters that fit the theme of the videos. I can use this talisman here stuck in my goo body to transform into any one of the edge totem animals. Tyrannosaurus, elephant, and Mothman. Maybe down the road, and if you like them, I can find out how to transform into even more critters. Paleontologists from half a century to over a century ago were doing things a little differently to how they are done today. Not really when it comes to finding and collecting fossils, though paleontologists are a lot more thorough and delicate today. We've gone away from using dynamite, for example. But when it comes to the actual science part, though, lots of things have changed. Most paleontologists today try not to slap scientific genus and species names on specimens that are so fragmentary that they can only tell you that a certain group of animals were around at a certain time and place. For example, dinosaur teeth are generally only able to tell you that Spinosaurs, Tyrannosaurs, or Ceratopsians were around, but they don't hold enough information to name a new species off of all that. Mammal teeth are a bit different because mammals only have 2 or 3 pairs of teeth for their entire lives, so their teeth are less adaptable over very short periods of time and can help identify species. When the tooth shape changes, it usually means the species changed as well. For the last century, paleontologists have also been arguing over 2 schools of thought: lumping versus splitting. Lumping is the act of combining specimens into known species based on shared traits, while splitting is separating specimens from species they have been applied to based on differences. This is much stronger of a process today than it was even 15 years ago, and you can see lots of work done to name new animals from well-known specimens that have been resting in known species for a long time. Thanks to the fossil record's bias, there tends to be a larger number of fossils that scientists are not confident about putting a label on, but are somewhat confident they probably belong to a known genus or species. These are bits and pieces or relatively nice specimens, but they are missing the parts of their anatomy used to tell species apart more quantitatively. For example, the horned dinosaurs, or Ceratopsians, have bones in their frills that can help describe and identify species. This is because it seems that the frills of these dinosaurs evolved faster and were more genetically plastic than the rest of their bodies. One possible explanation for this is that the frill was used in socio-sexual behavior and changed pretty quickly to go along with behavioral and environmental changes, like the feathers of living dinosaurs. As such, the Ceratopsian dinosaurs have a long, connected history with the lumping versus splitting thing. For an example of lumping, over the last 140 years, as many as 18 species have been named for the Triceratops genus. Only 2 have survived to this day. And for splitting, you are now seeing lots of things that used to be lumped into the Centrosaurus, Styracosaurus, Pentaceratops, and Chasmosaurus genera split out into new genera. One such splitting was finally published by Robert Holmes and colleagues in the Canadian Journal of Earth Sciences in March of 2026. Chasmosaurus is one of the archetypical Ceratopsian dinosaurs. It lends its name to its entire group, the Chasmosaurinae, to which such famous faces as Torosaurus and Triceratops belong. Like many dinosaurs found and named at the end of the 19th and start of the 20th centuries, it is known from dozens of specimens ranging from world-class to pitiful eroded mush. The very first remains that would go on to be called Chasmosaurus were found by Lawrence Lamb of Lambeosaurus fame in 1898 near Berry Creek, Alberta. This specimen was crappy by today's standards, just the bar that separates the two holes puncturing the frill that rudely breaches the back of the Ceratopsian skull and a little bit of the border of the middle part of said frill. This specimen would become the holotype, or name-bearing specimen used to describe a species of Monoclonius belli. Monoclonius is a convoluted, dubious wastebasket name with an extremely long history inappropriate for this video. Suffice it to say, the name didn't stick, and around 20 years later, paleontologist Charles H. Sternberg and his sons would find many more skulls in Alberta with striking similarities to the original material, enough to pull it out of the then valid Monoclonius genus and into a new one. Their first idea was to go with Protorosaurus, in reference to the giant Torosaurus of the US Southwest, but the name was taken by an archosaur from the Permian that used the root words to mean early reptile rather than before Torosaurus. I mean, hey, that just means Prototorosaurus or Archaeotorosaurus are still available. They went with Chasmosaurus, which means opening reptile because of them big ol' holes. Over the next 80 years, scientists found dozens of specimens from Canada that look quite a bit like the ones used to name Chasmosaurus belli, with some sporting all manner of minor or major differences that have had these scientists coming up with all sorts of nifty names and analyses for these names. One of these was a second species of Chasmosaurus that has been around nearly 90 years, only to be finally slain in a completely satisfactory manner. That second species is called Chasmosaurus russelli, in honor of the guy who found it in 1936, Loris Russell. It was described by Charles M. Sternberg in 1940 in the Journal of Paleontology using a single moderately well-preserved skull as a holotype, a skull missing a frill for the paratype, a crappy frill border, and then one other specimen for good measure. The holotype, CMN or CMN-FV 8800, is nearly an entire skull, missing only the jaw and half of the frill. It was found by Russell while doing geologic survey work for the Geological Survey of Canada in the Manyberries area of Alberta, specifically near the former 1-4 research station. The holotype skull is the only one here that contains enough information for a species or genus level description. Scientifically anyways. The others lack the important parts of the frill that can help distinguish between species. For the next half-century, scientists would place a whole bunch of other Chasmosaur specimens into the species. So much so that other named species of Chasmosaurus would get lumped into it or split out of it. Chasmosaurus kaiseni was named based on a nice skull with rather long brow horns, which was taken out and used to name Mohoceratops before being sunk into Chasmosaurus russelli once again. Funnily enough, the species Chasmosaurus canadensis was implied to belong to the Mohoceratops genus before it got sunk back into Chasmosaurus belli. Plenty other specimens that have been placed into either Chasmosaurus belli or russelli have had researchers questioning their validity for decades. There have been a few teams to reevaluate what has been deemed Chasmosaurus, especially with the new discoveries along the Rocky Mountains, from Canada down to New Mexico, plus the giant Pentaceratops and its many relatives throwed a bunch more chaos into the mix. Paleontologist David Evans and colleagues rediscovered the quarry site where the holotype of Chasmosaurus russelli was found. In doing so, they found that the rock deposits that let go of the skull belonged to the upper portion of the Dinosaur Park Formation, meaning the skull was from the Campanian age of the Late Cretaceous, which is slightly different than the horizons from which all other specimens referred to Chasmosaurus russelli, or even Chasmosaurus itself, are from. See this diagram here? This is a rough estimate of where a bunch of Chasmosaur skulls have been found in relation to one another and within the Dinosaur Park Formation. Specimen CMN 2280, a reported Chasmosaurus russelli, is at the bottom, followed by TMP 1979.011.0147, TMP 1981.019.0175, UALVP 40, and CMN 8801. Skulls that seem to belong to the Chasmosaurus genus but of an unknown or indeterminate species. Then there's YPM 2016 and ROM 843, Chasmosaurus belli, followed by ROM 839, an unknown species of Chasmosaurus, CMN 2245, Chasmosaurus belli. Then there are 4 specimens much closer to one another in time and space than the others. TMP 1993.082.0001, an unknown Chasmosaurus species, TMP 2011.053.0046, a specimen of Vegaceratops, which was considered a species of Chasmosaurus for a long time, CMN 8800, the holotype of Chasmosaurus russelli and the topic of this video, and then TMP 1987.045.001, another specimen of Vegaceratops. To the upper left of the diagram, you will also see CMN 4137, the holotype of Vegaceratops, and TMP 1998.102.008, another possible Vegaceratops specimen. This segregation of Chasmosaur specimens in time and stratigraphy throughout the Dinosaur Park formation means that the holotype of Chasmosaurus russelli, CMN 8800, is separated from all other specimens applied to the Chasmosaurus russelli species by as much as 1 million years, enough to question whether they would all be the same species. Hey, mind if I just butt in real quick? Just throwing out a little reminder to subscribe and like this video. Share it around as much as you can. The more eyes, the better. So, Robert Holmes, Jordan Malone, Michael Ryan, and David Evans all took another close look at the original skull to see if it really can be considered a Chasmosaurus. This involved turning all its anatomical features into data to put into software that compares that data to the data collected for a bunch of other critters that have already been collected or are used from other researchers. In this case, the team used the dataset from Mark Lowen and team's description of the asymmetrically frilled Lokiceratops from 2024 to see where the holotype specimen of Chasmosaurus russelli would fit. Phylogenetic analysis can spit out a few different results depending on how you weigh each trait, how many traits you use, how many other critters you compare, and so much more that we don't necessarily need to get into it right here. Suffice it to say, the Holmes team got 3 major results. One had Chasmosaurus russelli most closely related to the Pentaceratops part of the tree. One had it most closely related to the Chasmosaurus part of the tree. And one was ambiguous and unable to commit to either part of the tree. This looked to the team like enough to justify pulling Chasmosaurus russelli out of the Chasmosaurus genus and into a new one. So they came up with Cryptarkus, or Hidden Arch. Okay, that's neat, but what about all the other specimens that were considered part of Chasmosaurus russelli? Well, since the team renamed the holotype of Chasmosaurus russelli, and since it turned out that the most important anatomical traits of that holotype were distinct from many of the specimens put into the species, the rest are now temporarily indeterminate Chasmosaurs of some type. Many of them were indistinct enough to already be Chasmosaurs of some type, but others are distinct enough with enough information preserved to potentially be reassigned to a new genus or species down the road. Interestingly, in their quest to redescribe and rename specimen CMN 8800, the team found another specimen with the same type of information preserved to identify it as part of the new genus, specimen TMP 2013.019.0038. This thing is pretty dang fragmentary. It's just the bar that goes in between the holes of the frill with a little bit of the top margin. But it matches the same bone in the Cryptarkus skull. It was found in Dinosaur Park Formation horizons in the 1-4 area by Wendy Sloboda, namesake of Wendy Ceratops, in 2013 on the Sage Creek Reserve about 5.7 kilometers east of the spot where the holotype skull was found. That's cool! We have a new Ceratopsian, and it was hidden in plain sight. I don't want you to take away from this that paleontologists of the past were stupid, ignorant, and didn't know what the hell they were doing. They did, but more data is more data. There are now 3 to 4 times more Ceratopsian dinosaurs known to science than there were when they named this thing Chasmosaurus russelli. Plus, now we have rather advanced computer hardware and software. We can reveal anatomical structures that were never observed with the naked eye that can help to place a critter more accurately into an evolutionary context. All good stuff, really. There was even a more recent example of this. Another species of Chasmosaurus was named in 2001, Chasmosaurus irvinensis. It wouldn't be until 2010 that it was found to be too distinct and renamed Vegaceratops irvinensis. There is plenty of individual variation among dinosaur species, and scientists will continue to get to the bottom of what exactly constitutes this individual variation versus interspecific variation. So, what does this all mean for the new dinosaur? Well, not much. Since this thing is very similar to Chasmosaurus and has been a species of Chasmosaurus for so long, not much changes on a practical down and dirty level. The major change is in how the critter is used in hard quantitative studies, but it also helps to broaden the understanding of dinosaur communities during the Late Cretaceous, as well as how these critters evolved. Cryptarkus rivals the largest known skulls of Chasmosaurus, so it probably got to a similar size. Let me bring in Mr. Man from
Animal Planet's The Most Extreme
to show you really quick. Chasmosaurus has been estimated to be around 4.8 meters, 15.7 feet in length, and around 2 tons, so Cryptarkus would have been rather similar here. This is considered mid-size for Ceratopsian, with the biggest members Triceratops, Torosaurus, and Pentaceratops. Thanks, Mr. Man. Cryptarkus would have had a long, low-profiled skull with narrower jaws than the centrosaur part of the Ceratopsian tree. This was not much changed from Chasmosaurus, and both animals had much shorter brow and nose horns than other more famous Ceratopsians. The biggest difference is in the frills. CMN 2280, this guy right here, was originally put into the Chasmosaurus russelli species. It's now an indeterminate species of Chasmosaurus and technically the oldest form of the genus known. It had 3 lumps of triangular bone per half of the frill. Those lumps are called epoccipitals. The frill is sort of shaped like a flattened cartoon heart. ROM 843, a definitive member of Chasmosaurus belli, has a much more V-shaped frill with as many as 4 epoccipitals, including a very fused one close to the center of the frill. This one, CMN 2245, has a much more square-shaped frill, with 2 big pointy epoccipitals sticking out of the corners of the frill. If we take a look at a few different frills really quick, you will see a good comparison of shapes. Here's a Guhaceratops, Utaceratops, Pentaceratops, a potential Pentaceratops, CMN 2280, ROM 843, and our Cryptarkus frills. As you can see, the Cryptarkus frill seems most like Utaceratops and Pentaceratops. It even has some epoccipitals folding in towards the middle of the frill, perhaps a detail missing in some of the paleo art of this animal, but it might reflect a change in how these animals evolved. Another interesting thing is that the Chasmosaurus lineage/clade has a nose horn roughly in the middle of the snout. Cryptarkus has a nose horn positioned closer to the brow horns, serendipitously like that of Utaceratops. Something that kept Cryptarkus hidden for so many years is the level of resorption of its horns. Where the bony core of the horns is absorbed, gnarly stumpy horn cores replaced it. The brow horns are resorbed, and so is the nose horn to a certain degree. This isn't something that every Cryptarkus would have had, but rather something this individual presented. Resorption usually occurs in older ceratopsids. When you consider the Pentaceratops lineage, one might think of long brow horns, and when you consider the Chasmosaurus lineage, you might think of short stubby brow horns, and so did paleontologists for decades. Due to the short, resorbed, almost missing brow horns of CMN 8800, people attributed it to Chasmosaurus. However, with new discoveries such as Utaceratops, an older member of the Pentaceratops lineage with short brow horns, it's now understood that members of the Pentaceratops lineage, around 76 million years ago, had short stubby brow horns, as seen in both Cryptarkus and Utaceratops. By the time of Pentaceratops, long brow horns were all the rage in chasmosaurine fashion and would stay as a staple of this group till its end, with Triceratops. Let's take a quick trip back in time to the 2024 Dani Barrera Guevara-led paper that reassessed the geologic formation that the Mexican Coahuilaceratops belonged to. I made a video about this paper, so you should just go watch it before continuing this video. Link in the description and comment section below, or watch it after this video. In that paper, the team hypothesized a paleobiogeographic evolutionary scenario for Laramidian North American ceratopsians. This author team included CMN 8800 in this scenario, back when it was named Chasmosaurus russelli. The scenario shows a contiguous ceratopsian population around 81.5 million years ago along the coast of the Western Interior Seaway, which gets separated by the transgression of the sea by 81 million years ago. These separated populations became distinct by 80.5 million years ago. The sea regresses, allowing the two populations to commingle, represented here at 76.5 million years ago by Vegaceratops and Cryptarkus. This intermingling produces new forms by 76 million years ago, like Chasmosaurus in the north and Utaceratops in the south, now walking across North America now that the seaway has receded, explaining the 2025 report of Chasmosaurus found in Wyoming, which has still yet to see any official scientific publication. The northern Chasmosaurus lineage goes extinct by 74 million years ago, leaving only the Pentaceratops lineage, with Cryptarkus and Vegaceratops possibly the earliest member of this lineage. By 73 million years ago, we start to see the Pentaceratops lineage make its way further north as the sea regresses, only to be cut in two again by the transgression of the sea, eventually resulting in the Anchiceratops lineage in the north and the Triceratopsini lineage in the south. With that southern lineage allowed northward as the sea regresses again, it pushes out the northern lineage with Regaliceratops, the last known example, by 68.5 million years ago. This scenario is not actively contradicted by the Cryptarkus team, but they offer up a different scenario that does not see anagenesis of a bunch of American Southwest ceratopsians as part of the Pentaceratops lineage. Instead, they posit that all of these animals are splits or branches of the same tree. In other words, perhaps Cryptarkus is part of the Chasmosaurus group that convergently evolved Pentaceratops-like features. Only more specimens that help fill in more gaps will help clear the situation more, or maybe they will make things even more complicated. With the evolutionary parts out of the way, what could we expect Cryptarkus to have seen when it was alive? Since Cryptarkus comes from the top of the Dinosaur Park Formation, it may have been living alongside dinosaurs such as Scolosaurus thronus, Styracosaurus, Vegaceratops, Lambeosaurus, Procerolophus, Spheratholus, and Daspletosaurus wilsoni, plus all sorts of other critters like Ashtarchoterosaurs, mini mammals, too many turtles, possibly freshwater plesiosaurs, bunch of crocs, fish amphibians, invertebrates, and much more. It was potentially the standout of the Pentaceratops lineage, accompanied by the Centrosaurs and the Cosmoceratops-like Chasmosaurs, like Vegaceratops. Hopefully more of this animal is found someday, whether in the field or under our noses. If you liked this video, please leave a like, subscribe, and leave the lowest effort comment you're capable of for that sweet algo juicing. Also make sure your account is not in restricted mode, otherwise you might not even be seeing my videos. I'll provide a detailed step-by-step instructions in the comment section below and the description. I'd now like to thank my patrons and channel members. Ray, Staniforth Hopkins, Christoph Hubinger, Coleman Forestry, Isaiah Garza, Josh Infantine, Rudy Redgrave, Teeny Dragator, Iberospinus, Monitor Man, Jim, Gene Miller, Little Z, JD Trash, Manon Gaudreau, Greg Noneman, Urban Hermit, and Michael Murphy. These fine folks got to see this video a week ahead of the rest of you, so if you want to be like them, I have exactly one $1 tier on Patreon that gets you a ton of perks the average viewer doesn't get, and there are 2 channel member tiers at $1 and $5 respectively. If you stuck around to the end, then thank you so much for watching, and let me know what other topics in the life and earth sciences I should cover next. I read those comments you goblins make, and sometimes I even reply wryly. But this has been Edge Science, so see you in the next video.